ActiveState, as you probably know, they have a product called Staccato, and John's going to talk about microservices. Today our speaker, like I mentioned in an email earlier, used to be Bernard, was Bernard, but he came down with the flu. John works very closely with Bernard, and really looking forward to hearing from him on what he's seen in the developer space with his customers. John was at Sun for a long time, where he was a Java advocate. So he's kind of come from the developer side, and now is working also with some DevOps teams. So John, whenever you're ready, come on up.
Good, thanks, Jim.
Sure.
Well, good evening and welcome. It's a pleasure to be here. Thanks for everybody for coming out to this. Can you hear me okay?
Sure. Yes.
Okay, good. So, quick works. So this isn't me, as you could probably tell. This is Bernard, who is going to speak tonight. Unfortunately, he suddenly became ill. And I imagine a lot of you people came out to see him. He's an amazing person, really great speaker, tons of awesome experience. And unfortunately, I don't have much of that, but I do want to kind of qualify myself a little bit. So my whole career has been software development, with some side trips into, as Jim mentioned, advocacy or evangelism. So I've worked at various companies, and I just want to tell you a small segment of this, just to give you an idea. I was in a startup 2.5 years ago, and I was responsible for the entire software architecture, and I basically built it out as microservices before microservices was a big buzzword. I'd never really even heard of microservices, but it turns out the architecture was microservices based. And I've had a fair amount of experience trying to get enterprise apps working that would maybe be considered microservices based. And so this is back then, back in the old days, like 2011, and or 10 maybe. And so I spent a ton of my time in the weeds, working in the plumbing, trying to get all this stuff working, coordinating multiple, dozens of coordinating services, dealing with logging across multiple servers, across multiple data centers. And I spent most of my time, like many sleepless nights, dealing with this stuff. And anyway, the startup, unfortunately, there was other issues, they didn't make it. And then while they were kind of in the midst of plummeting, I came across platform as a service, and specifically Staccato. And it just blew my mind. It was like a sea change in my life. I almost look at my life as before PaaS and after PaaS. And it just blew me away because I realized how many months of effort I could have saved, maybe years of my career, if I had had access to tools like a PaaS, instead of rolling all this stuff myself. And so I actually called ActiveState and I said, hey, I really love what you're doing. Do you have any developer jobs open? And they said, no, but we have a developer evangelist job open. Do you want it? And I said, yes. So I jumped on board. They're based in Canada. I happen to be here. I spent about 50% of my time doing what I'm doing right now, evangelism stuff. And then the other 50%, I kind of negotiated to stay on the dev side is what I like to do. So I don't want to lose that, and I quite like it. And then the next thing I want to say is, so maybe 2 months ago or 3 months ago, there was a meetup at maybe eBay or Cisco, I can't remember where it was, where Adrian Cockcroft gave a presentation on microservices. That also blew me away very extensively, and I was very impressed by, first of all, his presentation, second of all, how much of what he spoke about lined up with what I've been working on, and specifically in the last couple of years with ActiveState. So I've been writing a series of blog articles describing microservices based on kind of the genesis of that was Adrian's talk. And it's just sort of become a thing with me recently. So Bernard was not able to make it, but I'm pleased that I have the opportunity to discuss some of this. The other thing I'll say is I'm going to be showing Bernard's deck, but he's more of a visionary than I am. I'm more into weeds, so I'm probably going to cannibalize it a bit, and I hope he doesn't cringe too much when he watches the replay. But I'm also going to skip through some of it and try to get into the technical side pretty quick. So this is a given. We are moving so fast. Technology is moving so fast. enterprises are not able to keep up, not even close, right? Enterprise has these legacy teams in place, legacy software, legacy customers, legacy everything. How can they possibly move in an agile way to keep pace with everything? It's a really difficult problem. And so there's many ways to deal with that, many things that are happening. But the unfortunate side to this is that for large enterprises is effectively, large enterprises these days are competing with who? They're competing with startups, right? So, you know, the video industry competing with Netflix a few years ago, right? So, you know, Blockbuster and media. It's really not it's not really a fair competition. Look what Netflix had, right? They didn't have a lot of legacy apps or code to deal with, legacy customers really, when they revamped everything. They also had a ton of money to throw into this thing and buildings full of top shelf engineers and architects, right? So they had this awesome situation that most enterprises do not have, which is to revamp their entire corporation, their entire enterprise for something new. And Adrian was a key player here. And he was able to, you know, with his vision, he was able to move Netflix into this brand new kind of world. And the results of what he has done is still, you know, that's kind of, I believe, I would say it was what started this whole microservices revolution, even though it's been around for a while. So Bernard talks about this third platform, which is, you know, there's the mainframe thing, what, 30 years ago, and then client server architectures came after that, and the new one now is this kind of combination of these four: social, mobile, cloud, and big data, and that's where all the energy is going now. And if you want to succeed as a company these days, it doesn't matter who you are. It doesn't matter if you make tires or toothpaste or technology or whatever. Everybody needs technology, and to stay competitive needs agility, right? One thing I love about going to conferences is meeting people from companies that I never would have dreamed even cared about technology, right? Like as I said, toothpaste or whatever. It's just, it doesn't matter. It's every company these days needs web presence, they need the cloud. And so that's kind of where we're going. Uber is a really good example. Bernard talks a lot more about this, but there's been a huge impact on taxi companies since Uber came out. It's kind of like what Netflix did. What Airbnb is doing to the hotel industry, right? So I'm not going to dive too much into this, but it gives you an idea of some of the evolution that's happening with development these days. So the old world, we're looking at things like, you know, who's the competition for the old taxi companies? Well, it's other taxi companies. Today, with Uber, they're competing. This small little startup, right, is competing with the entire taxi industry. And for the user, the end user, the convenience of Uber is very high as compared with, you know, the inconvenience of waiting in a half-hour line for a taxi cab or whatever, or middle of the night, you know, what are the odds of a taxi showing up? Anyway, I'm not going to dive into this, because I really want to get into some of the technology, but there's just been this massive change moving, enabled by and driven by some of these smaller companies. So moving a little bit more into the technology, infrastructure, obviously that's needed by everything. Everybody needs something to run these applications on, whether it's on-premise and, you know, a data center behind your firewall with all these legacy racks, or whether you're making use of AWS or Rackspace or you know, whatever the infrastructure is. That's starting to become less of a deal than the actual applications, the building and development of applications. As a development shop or as any enterprise, I do not want to deal with issues about infrastructure. Why should I? That's plumbing. I mean, really, it's not what I'm doing. I'm an enterprise with things I want to deliver to my users, and the plumbing underneath should be completely irrelevant to that. So as you know, this quote that Bernard, I believe, has put on this, we're now looking at the battle of the apps. It's not about infrastructure, it's not about hardware, it's about applications, and then what's tied to that is successful delivery and development and all that of applications. And that's what we need to look at. So Bernard has some rules for solving the application bottleneck. I don't know how many weeks I have spent, months, waiting to get something provisioned for me. So let's say I needed an Oracle instance or something. So I submit a ticket and then I wait. And it's really disruptive to have to do that as a developer. I'm sure you're all aware of that, who's building software. I get all enthused, I've got this idea, I want to try it out. I think, okay, well I need this, I need a message bus, I need a database. I want to try it out and see if it actually works. And then I submit a ticket to IT and say, could you set me up with this and this and this? And then I wait for a week. A week later, I don't even remember what my thoughts were, where I was going with that. And all my passion and enthusiasm is gone. And probably I've been sidetracked to work on something else. Then they say, okay, here you go. A week later, 2 weeks later, here's your Oracle instance, go ahead. It's like, okay, you have to shift gears back again and go back into it. It's very disruptive. Another thing it does, which is dangerous in my viewpoint, excuse me, is asserts organizational power. As a developer, I want a database instance. Whoever is going to provide that for me actually has power over me, because they can either say, well, I'll do that now or I'll do it later, but it's up to them to control it. And that's only bad because it causes maybe friction. I'm going to get resentful if it takes 3 weeks. And then they're feeling pressure from me. I might call them saying, what's going on? I need it now. All it can do is create friction, and it's a bad thing. How much better would it be if I, as a developer, can just click a button to get everything I need? That's kind of the whole point. Adrian talks about this. Every microservices talk I've ever been to talks about this. I'm a big fan, obviously. Platform as a service. And now I'm going to pause for a second, because I'd like to ask like 4 or 5 questions. How many developers are in the room? People that sling code for a living. You got an idea for that? Okay. And then people that, I don't know if you've included yourself, but if you're in IT or maybe DevOps or whatever, how many? Oh, it's okay. These days, DevOps people tend to sling a lot of code too. And then how many people here are familiar with platform as a service, as fairly comfortable with it? Good. What's really cool is I've been really following this. And 2 years ago, I'd go to a conference, cloud conference, famous cloud conference. No one had ever heard of PaaS. And it's obviously gaining great momentum, to the point where I go to a presentation at Java 1, and they don't even bother to define the acronym anymore, because everybody's starting to really understand what PaaS is. And it's still gaining adoption. It's still a little bit slow, but it's really moving forward. And what Adrian pointed out is that you can't really have a successful microservices deployment and delivery cycle and team and everything without some major tooling in place, and PaaS is a good example of that. So it eliminates a lot of the plumbing that you need to worry about as a developer, and that's the whole point. Oh, and another thing that's very important, it enables late binding. So what that means is late binding. In this context, it means you can deploy an application somewhere. You don't care where that somewhere is. You just care that you're deploying to this PaaS thing, this platform. The platform can run on your laptop, or it can run on OpenStack, or it can run on AWS, or Rackspace, OpenStack, Rackspace, or whatever. It can run, or VMware, any VMware system. It can run kind of anywhere. As a developer, you should not care. So when I was building that app I was telling you about earlier, I started working on Google App Engine, and I was starting to get locked in to a whole bunch of things with the message bus and a whole bunch of other things that required me to make decisions that would be like, this company is now tied to Google for the rest of our lifetime. And that really, I did not want that. So I had to step back and build the app so it was independent of Google. Nothing against Google really, but I just didn't want to lock myself into any specific provider. And that's this whole thing about late binding. When you build an application, you want to be able to deploy it to the PaaS. The PaaS should be able to run anywhere. Here's another interesting thing. Many companies I've worked at, including Sun, big surprise, they're Java shops. So, okay, you can use any development language you want as long as it's Java. You can use any framework you want as long as it's Spring kind of thing, which is, got some advantages. But often there are tasks and requirements that would be much better served by some other technology stack. So in the old days, you make a decision. We are now a Java shop, or a Ruby, maybe Ruby on Rails shop. That decision sticks with you for the entire life cycle of your application. I mean, possibly for years or decades. And it has some advantages, but it certainly has some disadvantages too. It means that I guess all the developers are sort of familiar with this big monolithic thing that's all built in Java. They should all be familiar with Java and Spring or whatever. But I've worked at many companies where we bring in these new hot developers that are super passionate about Ruby or JavaScript. And we say, well, no, you have to learn Java, and then you have to code in Java. And what I find happens is the developer then spends the day kind of struggling with Java and basically griping and complaining about it. And then they go home in the evening and they go and work on their open source, JavaScript project. And then they show up the next morning at 10:30, like all bleary-eyed and totally inept of working because they've been up all night working on the cool stuff. So one reason to allow polyglot, multiple languages, is to meet your development expertise. But there's other reasons too. For a specific purpose, you might know that Node.js with MongoDB is much more effective than using Java, Spring, MySQL, or whatever. There's many situations like that. And the main thing is if you lock yourself into a technology stack at day one, you're stuck with it. With a PaaS framework or foundation underneath of you, you can basically say, well, I want this tiny component of my whole application to be built with Ruby on Rails, for example. And it's much more reachable using a PaaS. So this is sort of the first bullet is the same as what I said, the approved stack of a corporation. We don't want to have this, everybody uses Java kind of thing. Very important also that the APIs, the use of APIs to access and manage applications, there's so many advantages with that as well. And basically the whole point is you would assemble an application from components, the components that make sense. Instead of having this big monolithic application, again, you've got components maybe, but they're in libraries that you access. Instead of that, everything's completely, very, very loosely coupled. And the components then would intercommunicate with themselves, but they're not dependent, they're not coupled with each other. And it just gives a lot of powerful advantages. And I think we talked about those shortly. I'll get into that in a second. Another thing that's, I don't know how many weeks of time I've struggled with companies is if things are different between your various environments, so for example in dev versus QA versus staging versus production and versus maybe a demo system and et cetera, et cetera. If there's a slight difference between any two of those environments, it can cause incredible havoc basically. And I've seen a company almost go out of business because of this. QA had their environment set up, and they'd be then saying, okay, this is ready, let's ship it to production, and then it would go out to the customer, and there'd be a slightly different configuration. And specifically what happened was there was an IP address in a configuration file instead of a host name, okay? And it was very dangerous. We almost lost our biggest customer because of this one thing. Developers were up all night for days on end trying to solve this. It was looking like it was a different problem. It was looking like a data problem in the database. It didn't look like a configuration problem. Anyway, the point is, if there's any discrepancy between the various environments, all bets are off. And so it's really important that Bernard talks here about shared artifacts. Basically, it means that anything that's comprising your application should be identical across your entire organization. And it says here leverage Docker. I would say leverage some sort of container system that's a very well-known pattern, whether you're using Tomcat or other containers. Docker is pretty awesome. I do want to mention that Staccato is I'm pretty sure it is the first commercial product other than produced by Docker themselves that incorporated Docker. We saw the power of Docker from basically the day they unveiled it at PyCon 2013. Solomon Hykes did this presentation, and I think it was the highlight of the whole show. And immediately after that, our engineers said, okay, this is great, we're going to incorporate it. So with the containerization of Docker, every container is isolated and identical, really. But I do want to make a very important point, and this is missed a lot, is that Docker, as powerful as it is not a PaaS at all. It's a good building block for a PaaS, but a PaaS is so much more. Orchestration of containers, security, auto-scaling, high availability, all that stuff. It's not inherent in Docker, Docker is great as a building block for it, but something at a higher level is needed. And PaaS is a really great example of something that can make use of Docker to achieve all this stuff. Another thing that's important is don't rebuild this legacy of stuff that nobody understands. And I've seen this multiple times too. You hire this hotshot developer, he comes in, builds an entire framework. Let's say a new framework, like for example, maybe Ruby on Rails, but on PHP or something, right? Okay, so he spends 6 months building up this very powerful framework that works perfectly for our domain and our purposes and our requirements. And then he quits, and nobody understands how to maintain this thing. Very, very dangerous. So don't do that. Use the tools and the technologies that are, are proven and true, tried and true and all that, and also known by the general world. Okay. Design for scale, that's also really important. The common pattern that I've seen multiple times, so let's say a startup, they build their application out, they do the proof of concept, they get it in front of their customers, they sort of evolve it, and then maybe 3 months before they're thinking of shipping it, they say, oh, you know what, we're going to have to deal with scaling. And so they say, okay, let's try stress testing this thing with however they want to do it. And everything keels over, and they end up having to re-architect half of their application to support scaling properly. And that's not the way it should be done. It's the opposite. Scaling should happen from day one. From the very first second you see anything on the screen, if you have a hello world screen and a button that says hello world okay, that's your entire application so far, like that's day one you're building it. It should be able to scale to like 10 million users. And, but who wants to work on scaling when you're first trying to get your application out the door, right? Or just even spec'd out and designed. And most people, I sure don't, I'd rather get the app going. But when using a platform, like a PaaS, would allow that for you from day one. So you build your hello world app, it's like 20 lines of code, push it out to the PaaS, and then you can scale it with a click of a button to support 10 million users. And then you can know how it responds, you can implement some instrumentation and measurement, which also is part of the PaaS, to detect how the page load times are and everything you might need to know. And then once you've got that in place, you just keep building the application, make sure you keep testing the performance, and you'll know when something comes in that breaks it. Much better approach than dealing with scaling sort of soon before you ship, or worse, after you ship and everything keels over, right? Okay, the infrastructure of the future. How am I doing on time? I think we started in 15, okay, good. So here's, this is a pretty good example of sort of the stack here. Starting with the infrastructure layer there, it should be independent, it should run on, you should be able to build out your applications for any infrastructure. This, when I say application, by the way, I mean microservices, just as important. And you know what I'm going to do, because we've got 15 minutes and I really want to cover more on the microservices world. Well, I'll finish this slide. Any infrastructure, containerization of some sort, Docker is a really good example, and then a PaaS that sits on top of it. That's what Staccato is. It's the platform as a service. Making use of Docker containerizations and we'll run, or containerization, and we'll run on any infrastructure. So if you want to try this out, feel free, go ahead. You can download Staccato, a PaaS, right now while I'm talking, boot it up on your laptop and you'll have the full PaaS at your disposal with 2 or 3 operations. It doesn't take a lot to install this thing, and then you can build MongoDB apps with MySQL, with Node.js or Java, Spring, MySQL. You don't have to install or configure anything. So the next thing I want to do with the next maybe 10 minutes I have, or even 5 I can cover, is I do want to just buzz through some more. I wish I had an hour, because, or maybe 2 hours, because I'd love to dive into some of the technology behind this thing. With microservices, you can have small teams focused on individual tasks. And what Adrian talks about is empowering the developer. So at Netflix, they were talking about being able to deploy an application to production from dev. It doesn't have to go through QA, 3 weeks later, get approved by all these VPs, get on staging, and eventually maybe a month later something gets out to the dev, right? I mean, can you imagine So Netflix in the old days, they were, as what I was told is they delivered their big old application as a single WAR file, right? And can you imagine the process involved to make a change to this? It's huge, and it's just mind-blowing, and it's what most companies do, right? So imagine the power that you would get if instead of having to redeploy a big old WAR file, you could just redeploy a small, tiny portion of this thing, and in a way, deploy it in a way where you can easily roll back. And what they were doing is deploying multiple versions of the microservice, for example, leaving the old ones in place, and you can alternate between them, route between them by naming, basically. So if I deploy version 7.2 of my microservice, version 7.1, 7.0, maybe 6.5.4 is still out there, and if something goes wrong with version 7, whatever I said, it could just easily be redirected to an existing version that's still out there. So it's still running on the network, right? It very much empowers developers. This is really exciting from a development point of view. It also gives you this rapid ability to deploy like in minutes as opposed to in weeks or months. So while I'm still here, I want to mention some of the challenges. A lot of people talk about the power of microservices, but you really want to, if you're going to move into this direction, you really want to think, take it very, don't take it lightly, I guess. Microservices are much more complex, really, than monolithic applications. If you have a 3-tier monolithic application, first of all, everybody understands it. And second of all, it's nicely contained and everything's in one, let's say one VM or something, one memory space, or maybe 3 for each tier, right? When you start splitting it off into dozens or hundreds of microservices, that's like way more complex and almost on every level, except for the individual microservices themselves. A problem that often happens when you have these complex microservices architectures is just trying to understand them, trying to visualize them. And you see these diagrams with all these connections between hundreds of microservices. It's almost impossible to determine what happens where. Tool sets, they're still evolving. PaaS is a really good tool set for microservices, but it's got a long way to go, or at least it's evolving quickly as people discover new patterns as they're building microservices. It's also a big culture shock. Let's say I'm used to working in a 3-tier application thing. I really get it. I understand how it works. Suddenly I have to move into a new world. It's kind of difficult. And then there's still not a lot of experienced microservices developers out in the world yet because it's a relatively new thing. How much time? I want to make sure there's time for questions.
Yeah, about 10 minutes.
10 minutes. Okay, I'll take just a couple more slides. There's so much I want to talk about. So I talked about this first one, immutable code service patterns. This is where you basically don't change an existing microservice. You leave it out there running. You deploy a new version that the old one doesn't change. It's still sitting there available. It's still working. Avoiding trunk conflicts. What that means is don't have a single Git repo for your entire, for hundreds of microservices. You need to have a single repo for each individual microservice. And similar to that is having dependencies. So if you don't have one big manifest that specifies, well, we have to use Spring, 7.8 or whatever the version of Spring is these days, that kind of spans your whole application. Each microservice should have its own manifest specifying its dependencies independent of every other microservice. I'm going to skip over some of these. These are just practices with microservices. You might have heard of Chaos Monkey from Netflix again, where they deliberately break portions of their application to do it in the middle of the day where everybody's caffeinated and awake instead of at 3 in the morning where it breaks by a customer. And you really want to eliminate anything manual. So let's see, I'm going to skip testing right now. There's just nowhere near enough time for this. But it's interesting to talk about some of the DevOps side of this. In order to successfully build out a full microservices-based organization, you really need a DevOps mindset. You don't need that IT mindset where you need to submit a ticket and there's a centralized IT team that's responsible for everything. It just won't work, right? If I have Ruby microservice, a Java microservice, a Node.js microservice, et cetera, it's impossible to expect an IT team to be able to understand and manage all these individual components. The responsibility for each service has to be in a localized team. Conway's law is what states that the applications that are built will mirror the organization's structure. So if you have a big old, hierarchical company with, big complexities, your applications will look like that. What you don't want to do is invert that. Decide how you want your architecture to look, and then design your organization around that. Now that's no mean feat, right? I mean, changing an org chart is a big task, much bigger than just trying to re-architect something. So most companies aren't capable or equipped of just saying, okay, we'll just reorg everybody here. Who's going to do that? This is where the tooling needs to come into place. Platforms and services is a good example. Bring that in first and start building out smaller, small components of your applications, microservices, and then that'll allow you to kind of gradually move into this realm. And as you see the successes, you can then, maybe convince upper management to make the transition. But this is a much bigger topic than we can cover here. The 2-pizza team rule, that's from Jeff Bezos from Amazon. He says each team should be no bigger than what could be fed by 2 pizzas. So I don't know what that actually quantifies to. How many pizzas do we have today? 20 pizzas. So yeah, so that means there'd be 10 teams right in this room, I guess. Assuming all the pizzas got eaten and no one's either really hungry or really full. But it's more just a sizing suggestion. And another thing is the developer should carry a pager. I love Adrian's analogy here. He says the analogy is in a car, think of a car, instead of having an airbag, you have a 6-inch spike, steel spike, like sitting right in front of you as you're driving, right? And if that was actually the case, I know for me, I'd be very cautious driving, right? And having this airbag in place maybe makes me a little bit more complacent, and maybe I'll be texting while I'm driving, right? Not with the 6-inch spike. He says, introduce peril into the system. I don't know how valid that is, but in this case, it's peril for the developers. If I screw up and push out some code that's not bulletproof and rock solid and reliable, I'm going to get a phone call at 3 in the morning. So it motivates the developer to make sure everything they do is rock solid. So if I had another hour, I would go into a lot of how PaaS enables microservices and a lot more details about what microservices are. But I have maybe 1 minute to buzz over this. So Platform as a Service does things like cluster management. You, as a developer, should never have to worry about all this stuff. Clustering VMs. Failover resilience, that's a huge process, a huge deal to deal with it. And load balancing, routing, all this stuff. Automating deployment, consistent environment, self-service. All this stuff takes tremendous amount of time away from the development cycle, whereas I'm building an application, I want to just focus on that and do the best job ever and let all this stuff be dealt with from some other layer, like PaaS. A friend of mine was working in a company, a large enterprise in Santa Cruz, and he had to spend 3 months building out single sign-on for a few applications. And he was a very smart guy, but he'd never done anything with single sign-on. He had to do all this research, and he's looking up all the single sign-on frameworks. He eventually settled on Spring Security, which is a pretty complex beast in itself. And 3 months later, he still hadn't fully completed, and there were still bugs. With a PaaS, it's not on this slide, with a PaaS, a well-qualified PaaS, you should be able to enable single sign-on across all your apps or microservices or whatever with a single click. And that's kind of the whole point. 3 months, 1 click, which would be better. So there's so much more we could talk about. Again, there's a lot of stuff with PaaS that it gives you. Rollback, versioning of services. Polyglot we talked about. Monitoring and logging out of the box. You don't have to configure, download stuff. It's right there. Monitoring and logging 100 app instances across multiple data centers. That's a lot of work. What if it's all just done for you? So I wish I had more time. I want to take 5 minutes to address specific questions. So the floor is yours, and anybody has any comments or questions? Yes?
In one of your slides, you had this microservice pattern makes ops simpler and complex.
Yes.
So in our experience, we have felt only the complex part. Is there any simpler part that you have come across? Or basically, can you comment on this? What's your experience?
Yeah, good. So the question is, so the slide, maybe I don't know if I can find it. The slide had said that, let me just find it
That's
There it is. Ops is simpler and more complex. So yeah, that's kind of a weird bullet point. So it's simpler in that a team can focus exactly on what they need to focus on. So it's a stack. So it's, here's my microservice built on Ruby and MongoDB. So I can have like the world's best Ruby person, focused on that and MongoDB without, so it's much simpler in the sense that contained within this microservice is very simple. But if you then step back and look across your organization, huge additional complexity, because now I don't just have a Java stack with Spring and MySQL or Oracle. I have, here's that, right, Java, Spring, MySQL, and then here's Ruby with Redis, and here's Node.js with MongoDB, et cetera, right? This massive additional complexity. That's where the DevOps needs to come into play to make this even possible. Otherwise, it's just a huge, too much of a change. Yes?
I think a little bit of a comment in a way. I think the key in microservices and single sign-on is a great example of people having lots of trouble. It's all about, do I trust this service is going to be up? Before you write something, if you don't have a culture of trust within your company between your little pieces of family, you're not going to be able to pull off a service architecture. And how does that relate to your own experience?
Great comment. So your comment was about needing trust between, I need to trust that microservice is there and it's going to work and it's going to follow its SLA and its API. One way I like to look at microservices is, let's say I use Google Maps in my application, right? So I'm going to make these calls to Google, which provides this awesome, incredible mapping service that's for free almost. And but when I'm doing that, I don't call up Google and say, hey, you know what, I could use another parameter on the URL to zoom in to this 1.5 times, please. That's not going to happen, right? You're not going to get Google's ear on that. They basically provide this. It's this completely independent service, and I make it work with my application. So I do trust that they will provide this rock-solid, bulletproof API, framework or API for me. But I generally don't need to really interface with them all that much. So it's a much cleaner, and that can happen inside of a company or else. So when I'm building up my application, I'm constructing all these components that are built for microservices that are being delivered from within and without the company. And I recently had a meeting with a large enterprise that's also doing what Netflix did, but they're being very secretive about it, moving to microservices. And this was their challenge, is to how do we partition microservices up so that the things that are common to this and this and this and this are in some central place, and the things that are very specialized can be out on the edge. And they're employing startups and small companies and contractors and consultants to do the outside stuff, and then they have a core team, hundreds of developers, but they're all core multiple teams building specific microservices that are shared across the entire applications suite, which is huge, and maybe thousands of different services. It's a huge problem. It's a challenge. How do you actually architect this out? This isn't easy stuff. It might kind of come back to your thing about complexity. I mean, this is complex. You're very visionary, and we're kind of, even though microservices as a concept has been out for decades, look at Unix pipes and utilities and all that. That's kind of like a microservice, but it's now finally getting traction in the enterprise. The enterprise are saying, let's move away from the old style of monoliths, but the challenges are just huge to actually make it actually work. I don't know if that addressed that, but you're shrugging.
Oh yeah, no, it's more just like complexity actually is, if you don't trust the other things, the amount of communications you have to add, the amount of layer of management, all that baloney kills you.
Yeah, exactly.
You have to have a culture of trust.
So, exactly, you need a culture of trust to make this work. You also need a culture that's fully on board with this. And often you'll see some developers or managers or whatever that are kind of the old school and they're saying, well, that old stuff works. And if there is that, it's probably going to unravel. Maybe one more?
Sure.
Okay, another, yes?
Yeah, so actually it's related to that. So one of the things you said is inverting Conway's law. What would be your advice or comments or thoughts on doing this in a larger enterprise where that isn't evident, right? So how can you ease in microservices architectures in a larger enterprise?
Great question. So how can you ease in? So you're a large enterprise with all this legacy teams, legacy infrastructure, legacy structure really, legacy apps, legacy code, legacy customers. So how do you actually move into microservices? What a great question. So first of all, recommended for greenfield applications you're building. Don't tomorrow say, okay, we're gonna rewrite our whole application suite using microservices. Ease into it. So take something small. Often companies are using internal applications. So let's say you have an internal app that's used for managing events across your organization, or conferences and trade shows, let's say, or you're managing, I don't know, the fleet of cars that you're using internally. You might want to take that little part and start building it out using microservices. So that's one side of it. And the other side is make sure, very, very important, to pay close attention to the tooling that's available to ease this transition. Obviously, I'm coming from a company that builds paths. So I'm biased, but also I kind of gained this bias before I even joined the company. I really recognize the power of paths, and it really applies to microservices. So make sure you have the tooling in place for these small, let's say, pilot projects you're going to build out. Now, the other thing I'll say is that if you're a startup or if you're building up a new app and the requirements haven't been solidified, often the better approach is to build a monolithic app, get it out there today or tomorrow, and see how its requirements evolve. Don't immediately jump into microservices from day one, because if things evolve too quick, the microservices is just it's a bigger thing to deal with. So you get your monolithic app, or just get whatever you can out the door as fast as you can. Then your customers and users and tests and everything evolve the requirements, and then once you've got to a certain stage, then you can say, okay, let's migrate this now, piecemeal at a time, to microservices. But again, it's a kind of a new thing, and there's a lot of evolution happening. So I'm going to stop now. It's been great. I'm available after this presentation if you'd like to dive in a bit more, and I'm going to turn it over now to Jim. So thanks for your time.
Thank you, John.
All right, so this next presentation, what I'm going to talk about is more on the networking side of microservices, right? So like John introduced already, platforms are definitely, and tooling is needed for microservices. But specifically, one of the challenges is and depending on how micro you go, you are going to have some specialized needs on the networking side. So that's what I want to discuss. Just in terms of background, and I'm not going to talk too much about our product, but what we are building in Nirmata. I'm one of the co-founders. We still haven't launched our product yet, but we are building a next generation platform targeted towards containerized microservices style applications. So here's what we'll do. We'll start with the challenges itself and talk about why this is important, why you need to think about this. We'll look at some common solutions and patterns, and some of these, I'll give out some examples of what tools are out there, and so, at least in our experience, what pros and cons we've found. And then we'll look at, what we're building out in Nirmata and how that, in terms of service registration, discovery, routing, load balancing, things of that nature, how this works within the application itself. So first off, microservices, like John was mentioning, like you probably heard from other talks, lots of key benefits for development, right? And I totally agree with your point earlier that it brings complexity to operations. I don't think it makes operations easier in any way. It makes it more complex. But if you look at where the value is for businesses, it's in developing software faster, right? So in some ways, if you are part of operations or DevOps, you have to figure out how to, get on that faster agility cycle, right? But microservices is really, in my experience as a developer, it's nothing revolutionary. It's more evolutionary, taking together the best of what we have known for design practices, the best of what we have known for architectural practices, and also organizational practices, right? So you really need, for good software, you need design, you need architecture, and you need the organization. Without any one of these, you're not going to succeed as a software business. So microservices is just a label we're putting on it right now to bring together the best practices we have been doing, maybe for the last 20, 30 years, right? So back to even object-oriented design, or before that, back to some of the lessons learned through the SOA experiments, right, in the early 2000s, and now through what we're learning through DevOps. So really, but going deeper, what is it that defines a microservice? And There's lots of different views on this. There's some great blog articles. Chris Richardson, who was one of our presenters at the last meetup, has a good site on this. There's also some good capture of like patterns, etc. But to me, what this comes down to is you have applications composed of multiple services, right? But there are some key properties for each service that makes it very different than what we've done in the past. Here what we're talking about is each service is elastic, each service is resilient to failures, so it scales up and down independently, being elastic, but also can recover from failures in terms of whether it's the hardware, the network, compute, storage, whatever. Or it could be a software bug for that matter, right? It doesn't have to be infrastructure. Each service is composable. So you want to start with and build out on top of uniform APIs to be able to compose larger applications. If you're building a microservices application in your enterprise, just adopting REST is not enough, unfortunately. You have to standardize on some best practices within that category. Understand, use tools like Swagger, use other tools, and start building uniform APIs. Each service should be minimal. So this is not very different than modular design principles we have known for the last 2-3 decades. So every module, a good module, is loosely coupled with other modules, but highly cohesive within the module. Microservices are exactly the same. So you want a service to be minimal, but you want it to be complete in a business function. So really, it doesn't have to be like some folks have said it should be like 100, 200 lines of code. I think that's nonsense, right? It will be, even if it's a few thousand lines of code, that's fine. As long as it's minimal in what it does, it's highly cohesive, and it's loosely coupled with other services. So that's kind of what you're striving for, and we'll see how this impacts, when you talk about networking, especially for the elasticity and the resiliency portion. So, like we talked about earlier, traditional software monoliths are definitely easier to maintain, easier to manage and deploy, right? Things were fairly static, life was good, you kind of, if this was installed software, you got it from a vendor, an IT vendor, you had few, IP addresses you would allocate, and pretty much that was it. You pre-sized it, so it would scale to whatever you needed, and you were done. Nowadays, that's definitely not the case, right? So here we've taken a very simple example. If it's a monolith, let's say a shopping application, you break it up into multiple services, immediately you have to deal with new API endpoints. If each service has to scale up and down, you're dealing with allocating resources on your infrastructure and deallocating resources. You have to deal with resiliency at the software layer versus what you did before at the infrastructure layer. And you want to now start, looking at some of the DevOps best practices of starting to, like John was mentioning, how do you completely decouple your applications from your infrastructure? So very soon, and how do you kind of get to like environments across multiple clouds, across multiple, sites? So very soon, you end up with something like this, where a single application may be running in multiple dev test, staging, and production environments, and you have a pool of resources you're trying to manage. As if you're part of an ops team or a platform team, you want to keep that infrastructure as generic and as reusable as possible. Like maybe run some batch jobs when it's not being consumed by others. So that decoupling has to be done in a manner that there's proper scheduling, there's proper allocation and deallocation of resources. So not an easy task, and that's where a lot of the challenges on the operation side is. So let's switch to the networking aspects of services and service-oriented software or microservices, right? So there, the first thing is, if you have many components within an application, very often people gloss over this because maybe it's a boring topic or maybe it's just implicit, but naming is very key. If you don't name things consistently, you can't find them. So it's not just about registration and discovery. You have to start with some consistent naming. Maybe you use DNS, maybe you use some other techniques, doesn't matter, but everything needs to have a logical name, maybe within your environment, within your application, and then at the service level. if you have multiple services coming up and down on various instances, and it's not going to be as dynamic as we saw over here, but let's say, as you scale up, you don't know what IP address or port a particular service might be running on. Other services need to be able to take that well-defined name and find where an instance is. Now, this is not just traffic coming into your application, but it's also for traffic going east-west in your application itself. So you need, because services, there's a lot of, once you go to a microservices style pattern, there's a lot of east-west traffic, right? There's a lot of services trying to find other services, so you have to make that efficient, fast, and reliable in terms of how that works. The next thing you have to think about is, what are your flows? Just like we have done network design and architectures for larger, let's say, data centers, larger environments, now you have to think about your traffic flows within an application and to an application. So how do you get the right traffic coming in? What are the routes, whether it's URL routing, DNS routing, some other kind of routing and naming? And then how do you manage the flows, like which version of your service or which, let's say you have services running in different environments, who should talk to who? And maybe you want a shared environment. So you have a common Redis cluster or Elasticsearch cluster. You want to share that across your multiple DevOps teams. You may want to allow routes into that from other environments, but within, maybe you have some other systems where only certain named services can talk, right? So that level of routing and discovery, it's not at an IP address or port level. This is at a service and application level, and that needs to happen, right? The other factor here, which is very different, is these are things which developers need access to and need to do as part of their day-to-day job, right? So they will want to change this. It's not something which you set up in a router or in a load balancer and you forget about it, and you have to put in a trouble ticket to change that. This is something which happens day in and day out, where as applications are being delivered, deployed, scaled, and managed, you want folks to have this programmable routing and management type capabilities, right? So some options there are, let's say we talked about versions, but you may, or environments, you may also want to introduce special HTTP headers, which your tooling should be aware of to be able to manage your traffic flows. Similarly, on the load balancing side, it's not just about your edge load balancers anymore, which are controlling where the traffic goes within a data center, but it's load balancing in an application. So this could be coming in from a gateway type function for external traffic into the application, or it could be, again, for east-west traffic as one service tries to reach out to another service in the application. So that needs to be load balanced too, and most of the times you would not want this to hairpin out of the application into an edge load balancer and back into your application, right? So you need some kind of very scalable application-oriented construct to manage this. And once again, you don't want to manage this using IP addresses or ports. You want to do it using some logical, well-known names, some definition which correlates back to what the developers are doing. So those are, some of the main, three things like we talked about: naming, registration, discovery, routing, and making that programmable and customizable, and also then, doing load balancing within an application, and also traffic coming in from gateways into the application, right? So let's look at a little bit more about, what the solutions out there are and what we ended up building as part of Nirmata. But before we do that, one thing, so Nirmata is based on Docker. We fully embrace Docker as a container technology, and we're building on top of it. So just it's a one-slide overview of Docker networking. And so if you're not familiar with it, the heart of Docker networking is a Linux bridge, right? So traffic, when you set up Docker on a host, it will automatically, configure the Linux bridge. It sets up IP tables and, does port forwarding from the host port into a container port, so you have unique sort of endpoints for each container. So what we're showing over here is, let's say you have, you know, multiple ports you're assigning at the host level. Each service will have, you know, could be using the same port, but that's being managed because they're all running on the bridge. That's okay, they're getting a unique IP address there, and they might end up, you know, using the same service port. So this, if you're running this at scale, every host will have this sort of mini, you know, switch really inside of it, and will do this type of translation. Now there are, you know, there are other schemes and there's other ways to do this. Like one of the things we're also exploring is how do we partner with SDN controllers? How do we partner with, you know, even things like Open vSwitch and kind of bring routable IPs directly to containers, right? But here we're going to just focus on the standard Docker networking and how can you build on top of that for the service discovery, registration, load balancing, etc. So some of the requirements we started out with is, you know, and today in our SaaS, we're still using the Netflix components, Zool, Eureka, Ribbon. And definitely if you're a Java shop and you're starting in on this, even if you don't end up using the components, it's like a great treasure trove of architectural patterns, of information, of how to do things, right? But it is Java-centric. It does impose, you know, certain things you have to do in your programming language or in your client application itself. So if you're using their service registration and discovery, it's at the software level, so you have to write a client using Ribbon, which is their library, to do that. We wanted something which is more infrastructure-based, infrastructure in the sense of the container level, so you would not have to write specific code to be able to leverage the service registration and discovery. The other thing, like I mentioned, is we want to manage services and developer-oriented constructs, not IP addresses. So there's a ton of schemes out there where they try to fix the container IP and move that around when the container moves. We didn't really, you know, feel that approach was adequate for our product because we want to, you know, do things at a logical name level, not at an IP address or port level. We didn't want to come up with any new protocol to do this. So there are schemes like Weave, for example, does UDP encapsulation on your packet, sends it through a common router, and lets you do, you know, some shared sort of networking. We didn't want to go that route. We also wanted to stick to the standard Docker constructs and support that as a basic building block, not kind of, you know, come up with some other construct on top of it. Also, really we're looking, like I mentioned, for a complete solution, which had to be environment aware. And a lot of what we feel the appeal of our product is in the ease of use, is in the, you know, kind of the usability really. So that's what we wanted to focus on, is how do you make this dead simple, just works, don't have to think about it. So that's what we started out with, and we, you know, I'll show a quick demo of what we've built. But before I get into that, any questions or thoughts so far of what we've talked about?
You mentioned something about in the section we talked about APIs, but just something about headers.
Yeah.
Is that something to weave things together or for forwarding?
Right, no, good point. So one scheme, if you have, you know, a lot of services again talking to each other, you might want to, at the gateway level, inject like a unique ID for each flow. So that gives you traceability across service messages, etc., right? So that's one use of headers. The other thing you could do is you probably don't want to pollute your names with versions, right? Because versions come and go. So you could stick, you know, versioning information in a header. What I was referring to is if you're building some programmable routing component, you really want this to be flexible enough to say, hey, you know, this is Jim's test service with my own custom header. I want to go somewhere and say, if I see this header, route it to version, you know, 5.3. Right? So if I can do that, that's the most flexible for me as a developer. So that's one use of HTTP headers for that kind of traffic redirection. Now, the challenge with that is if you're using HTTPS, it won't work because you'll have to keep, at every hop, you have to keep, you know, reading or decoding the packet, re-encoding it, and that'll kill your performance. If you're using other protocols, you know, like thrift, protocol buffers, it won't work, right? So, but it has some, if you can stick with HTTP, it's a good way of solving some problems. Yes.
Can you talk a bit more about how you build service discovery? So I build service and I want to consume something.
Yes.
So how do you build that?
Right, so Nirmata, as part of the solution, has a registry built in. And rather than talk about it, I'll just show it as we go through and what I mean by that. But it's similar, if you're using, let's say, Eureka, the Netflix OSS registry, what you would do is every service comes up and registers itself and say, hey, I'm service, XYZ, here's the IP address I'm at, and here's the port you can reach me on, and then other services can go discover that, right? So what we're doing as you're deploying things in Nirmata, we're just keeping track of that and distributing it across all the hosts for that environment, so any service can look up any other service. So it's a distributed registry, if you will, from that perspective. All right, so let's spend some time just looking at the product and see how it works. So this is our, so I'll go back to, I guess, our main, let me find my mouse here, our main view. So this is kind of the main view of the application blueprint side of things. So this is where you would define, let's say, for example, and by the way, we have the benefit of being able to use our own platform for doing DevOps on our own platform, right? So I'll show you what our application looks like today, and you'll see there's some, like I mentioned, we're using some Netflix OSS components. We have MongoDB, but these are the services we've built out. And pretty much you can expand this, and there's a lot of detail you can configure for any one service. Some of the main things here are is you have an image, you have various options. We'll go deeper into the networking side. But really quick, just what I wanted to show over here is you can have, this is not a very large application yet in terms of number of services, but even then the dependencies are complex enough where you might want to see kind of which service depends on which, and this is static. This is not runtime dependencies, but just configuration, right? So the idea is your DevOps teams would set up your services using this kind of blueprint, and for each service they can go into as much detail as needed to define those services. Once you have these, and what we're going to do for our demo is look at this pretty simple shopping type application. And I already have this running right now in a few different environments, but basically what it has is an order service, a catalog service, customer, and gateway. Now of course if you're building a retail app, you might have a dozen more services, but let's just say these are the components we have, right? So once you've defined them, you are putting in your naming information that I talked about, and you're saying, here's what I want to call my services, etc. There's also a little bit of platform setup. I won't go into details here, but you can set up different host groups, you can set up different environment types. And here, for example, on AWS, where we're running this demo, I have two different host groups, one set up for production systems, one for dev host systems. And the orchestration components here will decide as you're deploying different environment types. So what glues that together is the rules that we have defined. And I'll just quickly show that as the last thing before we do. So these are the different types of policies. So you can have resource selection rules that say, hey, for this environment type, go to this particular backend cloud and a particular host group within that, and use the best available memory type of placement, right? So once you have that set up, really what this comes down to is being able to quickly deliver new environments, right? So I'll go into our environment side. I already have a few environments running. So what I'll actually do, and I think we have enough capacity, I don't know if I need to delete this, but let's just try and add another environment, right? So I'll call it shop 3, and I'm going to select let's say staging for my environment type. I'm going to pick my application here. I'm going to stick with the latest version. So we do have built-in versioning. So this is a version of the application blueprint, but it also correlates like the image versions you would use back on your containers. So this integrates into your dev test systems. I'm just gonna click through the defaults here. So here you can select which services, you can set up scaling policies, and we'll take a look at that a little bit later. You can set up routes like we were talking about for your gateway. So for each service, let's say I want to define a route coming in. So this is external routes into my service. I would say, I could pick a version if I had that, or I could just say, go to the service and on this port using this URL part, right? So if I go to the gateway IP address /orders, it will find an instance of that service and go to that. I can also set up within my environment, and we'll take a look at this once we deploy something, but some routing policies and rules, like which services should talk to each other. So let's just go ahead and deploy, and so here's shop 3, and let's click on that. Hopefully I catch it before, yeah, so it's pending, and what it will start doing in a second is it will start pulling some of the Docker images that it needs to run these, and we'll start running those, right? So we see some of them flipped into running, and the last one, I think this is the gateway. Yeah, the gateway is the largest image, so that takes a few seconds, right? So once it's up and running, what you would be able to do, and we can go back to some of the environments we had. So let's say I go to shop 2, which is my other staging environment. We're pulling, of course, like standard analytics, different parameters from the underlying, so this is logical at the application level. It's not, just at the host level. But you can also go back, and of course, if you're part of a platform team, you can look at the same type of information, if you wish, at a host group level. So let's say I go to this cluster. I have 4 containers, so it's evenly distributed here. I can go look at my stats from a host level, and I see there's a spike because we just deployed. So this is, where some more memory allocation, and if you go further down, it will show you a breakdown for each service. So now that we have a few environments up and running, let's play with these and see what we can do for the networking, right? So I'll go back to my environment section. We'll pick shop 3, which we just deployed. And let's see if these guys are up and running. So by the way, all of these are running Tomcat, and they have a very simple servlet configured. And all that servlet does is it helps you resolve other services. So you type in a name, it will say, can I find this service? And if it does, where did I find it at, right? So say, for example, here we are at shop 3. I'm in the catalog service. Can't see my other, let me pull this down a little bit. Okay. So I go to customer, and let's say I'm in customer or I'm in catalog and I want to find customer. So I'm just gonna tell the service, hey, look it up and see if you can get an IP and a location for it. So it came back and said, I found a customer service running on this host. This is my container address, and here's what I got, right? So I can keep going to that, and I'll keep resolving. So right now in my environment, we just had one customer service, right? So let's go and check that. Yes, I just had one. So let's say I want to scale that up. For some reason, I need more customer services. If I want to make this 3, let's see if yeah, so now it's gonna, in a few seconds, we're gonna see it will start deploying.
Is this AZ and regional layer?
So you are defining which host groups to use. So you could use different regions, and you're bringing in, our philosophy on this is you're bringing in your own infrastructure, right? So you bring your own cloud, you tell us which regions to place what in. So you could have environments on a region, for example, and that would work perfectly fine.
But what you just did, if I wanted to make that distributed across.
Oh, I see what you mean, yeah.
Is that something that?
So the way you would do it is if you have a pool of hosts which are in an autoscale group, and we integrate with autoscale groups for Amazon, then you would get that, right? Because ASGs would. So we don't try to override or hide what you're getting from your IAS. We're just orchestrating the application on top of that. So use your best practices, use ASGs for that, and it'll spread it across the sort of the availability zones. So now that we have multiple customers, let's go back and look again for Or actually, I want to do one more thing, right? So I have customers here. What was the other service we have? We have orders, right? So let's say catalog can talk to customers, but I want to now say, I don't want the catalog to be able